Hey everyone, and welcome to the 4th episode in the tile scrolling game series. I can't believe we're already to episode 4. Today is a really exciting day because we are going to be taking this just floating camera system where you just move around with WASD and look at the world to an actual player that you can walk around and jump, basically turning it into a platformer. And to do that, we'll need to set up a lot of backend stuff like the tile meta I talked about in the very first episode. If you're excited for today's episode, then make sure you hit that like button and consider subscribing. But anyway, let's just get right into this tutorial. Okay, so I have one new sprite called player, and then the sprite we've been using as the player, I just renamed to player old. So inside of the player, it's blank for the code, but I have quite a few costumes. There's this idol, which is just the dude sitting there like, what the? Okay, I just closed I closed the window on accident or something. Okay, anyway, there's an idol costume called idol 0, which is just the dude sitting there staring intensely into the void. Idol 1, which is just like a squishy squashy version, and then idol 2, which is a squishy squashy but with long arms. Then I have walk 0, walk 1, walk 2, walk 3, walk 4, walk 5, walk 6, walk 7, and that's just the walk animation. You do not want to know how long this took me to get looking somewhat right. It's still not the best. Like, what is that foot? Then I have player 12 is actually the hitting animation, so let me rename that really quick. Okay, that's better. I have hit 0, hit 1, hit 2, hit 3, hit 4, hit 5. This was a really fun animation to make. It kind of looks squished here. Then I have turn around, which is just for when you turn directions. I have climb 0, which is the climbing with his right side up, and then climb 1, which is the opposite. And as always, all these sprites and costumes will be in the link in the description below. Please use with credit though, because these took me forever to make. I'm still relatively new to pixel art, and this was a challenge. I had a lot of fun making them though. Okay, so to actually get this player working, we need to set up the backend tile meta system so that we have information about the tiles that we can use. So inside the backdrop, go ahead and add a when I receive create metas like so. Then we are going to make a new custom block called create tile meta, and this will store a bunch of information things in a list about the tiles. And go ahead and check run screen without refresh, and then run that in the create metas. And then in the very beginning here, let's go ahead and do broadcast create metas and wait. So inside the create tile meta, we need to make a list called tile meta, and this will contain all the information about the tiles. Then we're going to delete all of the tile meta here. Okay, so let me really quick explain how this is going to work. So basically, this list will contain a bunch of information about the tiles. In the tile meta, it would have first the ID, so say it's 1, then the name of the tile, stone, and then all the other information. So maybe if it has tile collision would be true. And then obviously these would all be in the tile meta, not the tile grid. If I click on that, now we have this little information in the tile meta. So now all we need to do to tell if stone has collision or not is just pull out item 1 of tile meta, changes to item number of the ID in tile meta of tile meta. So this item number of 1 is number 1. Now if we put this in here, this will give us the item of the list that corresponds to ID, which is 1 here. Now all we need to do is add 1 to this item number, and now as you can see it says stone. Then if we do +2, this will be if it has collision or not. So that's how you can grab any information by just using the ID. And say we duplicate this and add 2 and then dirt, and maybe it doesn't have tile collision, and add that to it, and now we do item number of 2, which is the dirt. You can see now if we click on that, it says false, so that means that dirt does not have tile collision. That's basically how the tile meta works. Now there's one little loophole. If say one of the values in the stone has a value of 1, it will confuse the system because it doesn't know if it's an ID or a value. Like whatever, say this is mine time and we set that to 1, well now it could get confused on which one's the ID. So we need to store the ID in a separate list, and then we can use that in this part, and it'll do the same exact thing, but the other list will contain blank values for all of these. It's a little bit confusing, but I'll show you what I mean. So go ahead and add a list called ID grabber underscore tile meta, like so, and delete all of that in the create tile meta. Now let's make a custom block to actually add a thing to the list. So make a custom block called new meta entry with a colon and then a space tile ID with a colon and then an input called ID, a label called tile name with a colon, and then an input called name, a label called has tile collision with a colon, and then an input called has collision. And for now, that's all we need because we don't have that much information to store in each tile, so just run without screen refresh. Now, all we need to do here is pull out the new item entry and fill in the data. So for item tile ID number 1, that is air. So the name of it will be air, and the has tile collision is false. Make a custom block called add tile to list with a colon, and then an input ID. Now, inside of that, go ahead and add the ID to tile meta. Then inside of here, all we need to do is add tile to list, do ID, duplicate that, and then do name, duplicate that, and then do has tile collision. So if we go ahead and start this now, in the very beginning, we have 1 as the ID 1, 2 as air, and then 3 as false. So that's working good. And if we duplicate this and then do the ID 2, which I believe is bedrock, let me check. Yep, that's bedrock. So we will put in bedrock here, and the has tile collision is true. And now if we go ahead and start this, now there's 2 different chunks. This is 2, bedrock, and true. Now we will have the same exact issue as said before, where the ID could match one of the inputs in here, and then it'll confuse the whole system. So we need to actually make use of this ID tile grabber. So let's go ahead and actually do that. To do this, we need to make ID tile grabber look exactly the same as this, except it only stores the IDs. So these 2 values in between are just blank. First, we need to make a variable called meta number. So that's the amount of items that we're adding to the meta, and we'll go ahead and set that meta number to -1. Then each time we add the tile to the list, we change the meta number by 1. So the very bottom here, all we need to do is repeat the meta number, add blank to ID grabber for tile meta. So now we just need to add the IDs here. So go ahead and make a custom block called add tile grabber ID colon, then an input called ID. Duplicate this and then change this to ID tile grabber of item meta, and then add tile to list blank, so that way it fills in that blank data. Then at the very top, instead of adding the tile to list for the ID, just add the tile ID grabber to list and put the ID inside there. Okay, so hopefully if we start this now, here we go, the spots for the ID in the tile meta is blank, but in the tile ID grabber, it actually has the ID. So you can see that it matches where these ones are blank. So basically what that means now, we can have data for like 1 in the tile meta, but it doesn't matter because it's using the ID grabber to get that item. And the reason we have to do all this extra stuff is because it makes it automatic for in the future. Say we have another parameter in here. I'm just going to do test colon and then input test. So this is going to be a number. Say this is whatever this, and that's that. Now all we need to do is add the tile to list at the very bottom here, then that test. And you can see now it works exactly the same, except now each tile has that one weird number we did, and it reflects that in the grabber. So we can go ahead and get rid of that now because we know that the system's working. So now that we have this system, we can grab any data from the tile meta. So let's go ahead and test that. I want to get the name of the ID 2, which should be bedrock. So all I need to do is do item number of 2 in the ID grabber, then do the item 1 of tile meta and put that in here. If I click on that, it's going to be blank. So to get the name, we just need to add 1, so it shifts 1 to the right. So if we add 1 to this and now click on that, it says bedrock. Awesome. And maybe if we do 1 now, it will say air. Now before we can continue with the other stuff, we need to go ahead and make all of the different tiles. So for 3, it is stone. Has tile collision is true. Next is 4, which is dirt. Tile collision is true. 5 is grass. Has tile collision is true. 6 is long grass, and that does not have tile collision, so I'll just put false in there. 7 is the flower, and that doesn't have collision either. Number 8 is wood. That also does not have tile collision. Number 9 is leaves, and that does have tile collision. Number 10 is leaf log, not logo, log, and that has tile collision. 11 is clay, that has tile collision. 12 is torch, and that does not have tile collision. 13 is bedrock dirt, that does have tile collision. 14 is a ladder, and it does not have tile collision. 15 is tin ore, it has tile collision. 16 is coal ore, it also has tile collision. 17 is copper ore, it has tile collision. 18 is silver ore, it also has tile collision. And last but not least, 19 is gold ore, and it has tile collisions. Okay, so now we have all the tiles set up, and if we start this game, you can see that the tile meta has all the information about all these tiles. So the flower doesn't have collision and all that stuff, and in the ID grabber, it matches that with all these different IDs. Now we can actually start on the player collision because we have the data in the background for these tiles. So go ahead and pull everything from player old into player. Make sure that that actually worked, and now that we know it worked, get rid of player old. For the camera movement, let's go ahead and remove these two ones here, and also get rid of the scroll X and Y. Okay, so now what we need to do is make a for the sprite only variable called X and a for the sprite only variable called Y. These are the positions of the players, and go ahead and set both of those to 0 and 0. Now inside of the tile manager, go ahead and scroll around until you find the little generate clone grid function, and remove the set scroll X and scroll Y. We no longer need those, because inside the player, we're going to go ahead and set the scroll X to X and set the scroll Y to the Y. And to clean this up, let's go ahead and make a block called reset, run without screen refresh, and put all those set variables inside of there like so, and run reset in the very beginning. Now in the backdrops, we can go ahead and move this broadcast create tile meta to the player, and now put that right underneath here. In the reset, we're going to go ahead and hide and go to front, as well as set the size to 250%. Then we will also set the rotation style to left right, and now instead of setting the X and Y to 0, we need to set it to the very middle of the world. So set the X to the world width times the actual tile size, pull out a backdrop of stage and change this to tile move step of tile manager, and then take that times 0.5, which will just divide it by 2. Duplicate this and take out the times 0.5, and then change this to world height, and do that for the Y. Now before we can test this, we need to make the camera move to the position of the player. So change scroll X by a times in here, then a minus like so, and put the desired position, which is X, minus its current one, which is scroll X, times like 0.3. Duplicate that and do the same for the Y. So change scroll Y by the Y minus scroll Y times 0.3. So hopefully now if we start this game, it should be looking like we are at the top of the world. Yep, you can see some trees, and if we change the Y by like -6, as you can see, it starts moving down. So that means the camera is properly following the position of the player, and it's smooth looking too. Now let's make the player show after all of that. Now in the loading screen, pull this broadcast generate world inside the player and wait right here. Then at the very end here, broadcast hide loading screen like so, and in the tile manager, remove the hide loading screen right here. And we need to change the loading instead of a when I receive to a when green flag click. Now you can see that when we click on the green flag, it will do some nice loading, and then it will fade out, and you can see the player is kind of stuck at the top of the screen. So now let's actually make the player go to its correct position, which is the X and Y and stuff. So inside the backdrops, broadcast tick position player, and we also want to change this to a tick position tiles. I'm not sure why I didn't name that correctly, but make sure you go back into the tile manager and change this to a tick position tiles. And make sure you position the player before the tiles, and the player, we can use that. So when I receive position player, pull out a go to block and do a go to X minus the scroll X here, duplicate this, and then do the Y minus scroll Y. If we change the Y by like -6, you can see that the player actually moves. Look at that. Or if we do like change X by 1, you can see it's actually moving like it would in the real world. Okay, so now that we have the positioning working, we can start working on the actual movement. So go ahead and make a custom block called movement and click OK. Run movement in the forever loop. Now before we can kind of do all the movement stuff, we need to figure out the current tile the player is standing in. So make a custom block called get current tile, then a colon, X with a colon, input X, label Y with a colon, and then input Y, and click OK. Then in the movement, go ahead and get the current tile X right here, and just input the X and Y. Now, to do this, we just need to do some rounding. Make a for the sprite only variable called player tile X, and another one called player tile Y for the sprite only as well. Go ahead and set the player tile X to abs of, and change this to floor of a divided by, and do X divided by tile move step of tile manager. Duplicate that and set the player tile Y to Y here. So you can see now in the very beginning, hopefully these get correctly set. Here we go, it's 500, and that's the current coordinate we are in. Now we need to figure out the index of the tile meta according to that tile X and Y. So make a for the sprite only variable called player tile index, and set that player tile index to a plus, and then put another plus in the right, and take the player tile Y plus 1, then add to that times operator player tile X times the world height. If we go ahead and show the player tile index, it should correspond to the item of the list that we are currently standing in. Now we need to figure out the actual tile we are standing in, so make it for the sprite only variable player tile ID. Set that player tile ID to the item 1 of tile grid, and change this to player tile index of tile grid. And now hopefully if we start, player tile ID should match the ID that we are currently standing on. So if we go ahead and change the Y by like -5, and you can see it's 1 because we're in the air, but if we go down to like the dirt, you can see that's 4, because if you check here, 4 is dirt. Or if we keep going down a little bit more, right here it's 11, because number 11 is clay. And now that we know the tile we are currently standing in, we can use that in our movement later on. So we can remove this for now. Let's work on gravity. So make a variable called y speed for the sprite only, and another one called gravity scale, also for the sprite only. And in the very beginning, set the gravity scale to -1.5. Now right here, change the y speed by the gravity scale, change the actual y by that y speed. When we start up the game, we should start falling. So yep, here we go, we just start falling faster and faster and faster. Wow. Okay, so let's actually make this have collision so we don't follow the world. Now a quick disclaimer, this collision system is heavily based off of Griff Patches in his tile scrolling game. I modified it to make it work for this game, but I just want to say that. Make a custom block called collision. Label X colon and input X, a label Y colon, and then an input Y. And you can see now we have this nice custom block. Then we want to go ahead and run collision and do 0, 0 inside of here. Now we need to make a custom block for the actual specific point of collision. So do a check collision point with a colon, and then an X and a colon, an input X, a label with a colon, Y, and then an input Y. Now we can check collision point inside the collision and just do the variable X, which is the position, plus the X, and the variable Y plus the Y. Now we need a variable that's called colliding, and set that to 0 in the top of the collision. And then inside the check collision point, we need to get the current tile X and Y. Then we need to check if the current tile we are on should have collision or not. If item player tile ID plus 2, which is the collision of the tile meta, is equal to false, which means it does not have tile collision, then we can go ahead and just stop the script. But if it does, then we set colliding to 1. You know what? Let's rename the X to DX and the Y to DY. That makes a little more sense. So let's go ahead and take out the gravity and make sure that the collision is working. Change the Y by like -5 in here. So right now, colliding is 0. Okay, that's good because we're in the air. But if we move on to something like the leaf, 1, or if we're in the ground, it's also 1. So collision is correctly working. Yes, we can finally use this now. Okay, so we can go ahead and change the Y speed by the gravity scale, and then move this collision underneath. In the Y here, go ahead and put Y speed because that's the direction we're moving in. Then we want to check if colliding is greater than 0, which means we've collided with something, and make sure that's in an if else. Then we go ahead and set Y speed to 0. Else, we go ahead and change player Y by the Y speed if the Y speed is less than -25, and set the Y speed to -25, that way we can't fall too fast. So if we go ahead and check this out, we should fall onto the ground below. Look at that, we fall on the ground. If we change the X by like 5 here, boop, 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 we should fall into the ground, yep, and we fall, and look at that, we fall on the ground. Now the collision is in the center, but it is working, so that is really good. Okay, let's make the collision more accurate so it's not just checking for the very center. So to do this, we need to make two variables for the costume width and height. To make a variable called costume width, and then another one, costume height. In the beginning, set costume width to 17, which is a little bit above what the sprite says right here. I kind of just guessed these values and moved them around until they worked good. The costume height is 24. I found that works really well. Now we can actually use those in the collision here and check a bunch of different points. We want to check for collision here, 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 and here, and then also here. That way it's a box around the player. So go ahead and do first the X plus costume width, then add onto that the DX here. Duplicate this and now do minus costume width. Okay, so this one is plus the costume width and then in the middle, so it's right here. And then this minus one is over here. Now let's go ahead and duplicate that and do the X plus costume width plus DX and then take out all this, duplicate this, and then do the Y plus the costume height plus the DY. So this is all the way in the top right. Duplicate this and then do a minus here. So this is in the bottom right. Duplicate this and change the X to a minus as well. So this is in the bottom left. Duplicate that and then minus and then plus. So this is in the left and then the top. So we basically created collision points for all around the player. Okay, so if we go ahead and test this out now, the collision should be much more accurate, or it'll just not work at all. Okay, really quick in the beginning here, I think why it's not working is because it's clipping. So go ahead and subtract off costume height. And if we start this should hopefully fall down now instead of getting stuck. Here we go, it actually falls, and look at that, it lands on its feet. Awesome. And if we change the X -5 here, or 6, you can see that it accurately falls off the edge, so we can move to the right, and you can see it keeps staying on there, staying, and then boom, it falls. Okay, so that's working correctly. Okay, so now we can use this to make the horizontal movement. Add another collision here, and input a new variable called X speed, like so, and put that on the X and 0 on the Y. Check if the colliding is greater than 0, which means we are colliding on the X axis. Set that X speed to 0, so we stop moving. And then in the else, change the X by the X speed, which I can't seem to find. Here we go, it's right there. Now we need to get the input, go into the backdrop, and add a new tick loop called tick get input, like so. And in the player, when I receive that tick get inputs, make a new variable called X input, like so, and then another one called Y input. Now set the X input to the key D minus key A pressed, and set the Y input to the key W minus S pressed. So you can see now that if we start the game, whenever we press whatever keys, it'll set the corresponding inputs correctly. If we press A, it's -1, and D is 1. If we press W, Y inputs 1, and then S is -1. So now we have the inputs. So now all we need to do is actually move the player according to those inputs. So underneath here, we can change X speed by the X input times a variable for the sprite only called move speed. So just change it by the X input times move speed, and then at the beginning here, set move speed to 0.5. So now if we start the game, you should see that we start accelerating. So here we go, we can move left to right, and we collide with the plants. That shouldn't be happening. Okay, now the reason for that is because I did this part wrong. Instead of setting it to all this, we want to set it to the item number of all that of the tile grabber. Yes, look at this, we don't collide with the ones we shouldn't. As you can see, we can walk straight through the grass and the logs, but if we start moving towards the wall, it immediately stops us, and so does the ground. Now, as of now, there is no friction or limit to how fast we can go, so we should probably fix that. So let's do a speed round of making a ton of variables. So make a variable called max speed, another one for the sprite only, just like the last one, called turn around speed. That's how fast you turn around. Another one called called friction. All these are for the sprite only, and that is good. So now for the max speed, let's set that to 5. The friction will be set to 0.8. Make sure it's a number smaller than 1. And the turnaround speed will be 0.5. Now we have some variables we can use. So in here, check if the x input is equal to 0, which means we're not moving. Then we'll just do blank, else we'll do what we have here. And instead of blank, let's set the x speed to the x speed times friction. That means we'll slow down. So if we start now, you should see that whenever we let go of the movement keys, we'll actually slow down. So you can see we build up momentum, and then when we let go, there we go, we slow down according to our friction variable. Now it's super slidey to try to turn directions, so let's fix that up. First of all, let's make sure we're not too fast. So check if the x input times the x speed is less than the max speed. If it is, then we'll do the movements. That way we can't go too fast. Then we need to check if we're turning around. So duplicate this, and instead of max speed, do less than 0. So that means that we are turning around. So if we're not turning around, then do that. But if we are, then we want to change, instead of times move speed, we want to do times turnaround speed. So that way we turn around a bit better. So you should see that we can no longer go super fast. Yep, we are limited, and it's not so hard to turn around. And to show you that this is working, if we say blank here and then say hello in here, as you can see, whenever we switch directions, it says hello momentarily. Inside of this else here, at the very bottom, let's point in direction the x input times 90. So that'll make us look in the correct direction, as you can see here. Now, whenever direction we move in, our player faces that direction. And you know what? We should probably also make the jumping go in the very top here. Instead of just setting it to 0, we can check if the y speed's greater than 0, then we'll do that. Otherwise, we can set it to make a new input variable, jump input, and set the jump input to key W press. Now we can set the y speed to the jump input times another new variable called jump height, like so, and set the jump height to 15 here. And make sure you do the times jump height here. Oops, I did something wrong. We did X speed here. I want to do Y speed. So you can see now, look at this. Whenever we're on the ground, we can press W to jump. Awesome. We can't do it while we're in the air. So this is working properly, and you should see that all the collisions are working. We can't jump through the ceiling, and we also can't like go on the walls and all that stuff. Just to test our system, if we go into the backdrop and change the grass tile collision to false, you should see that we can fall straight through the grass now. So you can see now that, look at this, we don't collide with the grass. Okay, let's change that back. Okay, so now all we need to do is do the animation, because we have all the platforming code and everything here. So in the position player here, make a new custom block called animation controller and run that right here. Now inside the animation controller, we need a new variable called underscore player costume. Now all we need to do is change that player costume by the speed of our player movement. So change player costume by the abs of x speed divided by like 25, say, then add 0.15, and that's our idle speed, and do that right here. Now let's go ahead and do an if statement, checking if x input times speed is less than 0, then we switch costume to turn around, and then we stop this script. So that's for when we're turning around. Now we can do the movement, so do if abs of x speed is less than 0.2, so that means we're pretty much slowed down. Then we can switch costume to 1, which is the starting costume of the idle animation, plus floor of the player costume, mod 3, which is the total amount of costumes, because you can see that the idle has 3. Otherwise, if we're moving, we need to find the starting walk animation frame, which is number 4. The total amount is 2, 3, 4, 5, 6, 7, 8. So it will be mod 8. Okay, so now we should have some basic animations in. Okay, we're idling, and then once we start moving, when we turn, it turns, and when we move, it actually starts like doing the move animation, but it looks a little weird. So we need to keep track of if we're in the air or not, and if we are, then we need to play a different animation. So make a variable called in air, and at the very top, set the in air to 0 because we are colliding. But if we're not colliding, change in air by 1. Now above here, we can check if in air is greater than 0. Now we need to check if we're going down, so check if the y speed is less than 0, which means we're moving down. Then we switch costume to walk, walk 1 and stop this script. Look at this, when we jump, it kind of freezes the current frame we're in. Then once we get to the ground, it starts walking. However, the walking animation looks kind of not sure what's going on. Oh, because I didn't do 4 here. Remember, the starting costume of the walk animation is number 4? Well, that was a mistake on my part. Also, just to save up resources, set the player costume to 0 in the reset loop. So look at this, we have animations, we have our collision, and we can even specify what tiles we collide with. I hope you guys enjoyed this episode. If you did, make sure you hit that like button, hit that subscribe button. But anyway, this has been Owen, and I'm out.